Ed Witten was once asked, recently actually, in the past 5 years, what about other approaches to quantum gravity other than string theory? And he said, what other approaches?
Right, of course he would.
And then they listed some like causal sets or loop quantum gravity. And then he said, well, the reason why string theory is supreme is because the mathematics of those are described in string theory or tend to be more and more. String theory tends to gobble up, whereas those don't tend to gobble string theory. So he said, if there's something to loop quantum gravity, I'm sure we'll discover it in string theory as well.
They already have a long time ago.
Oh, can you explain that? And what do you make of that statement overall? I was paraphrasing, so please don't quote me on that.
Oh, that's okay. I mean, what am I supposed to hire? His father was a good friend of my mother's. And
Lewis Witten.
Lewis Witten, yes. And I think, I don't know, here's something I realized recently. Ed used to give me advice. Edward used to give me advice. And I used to misunderstand it because I was too oversensitive to being criticized, and especially by him. For example, he would come to me and tell me, when I was a graduate student, he would say, you really ought to have a research program and develop it. And I said, but Edward, I have a research program, but he never was interested in mine. That's the way it felt. Well, not recently, but maybe 20 years ago, I was for a day at the Institute. I gave a talk and so forth. And he came over to me and he said, I have some advice for you. And I said, sure, what? And he said, you're really smarter than you look. And for people to become convinced of how smart you are, you should get out of quantum gravity for a while and work on condensed matter theory. Because there are a lot of people who are working on interesting problems, and people will get to see how smart you are. Now, I heard that as criticism.
Okay.
But I think he was actually trying to give me what would have been, if I couldn't have taken it because I'm interested in condensed matter theory. I'm interested in applying ideas from condensed matter theory to loop quantum gravity, and that would be one way to explain to Edward what we're doing. But I took it as a strong criticism, whereas I'm sure he meant it kindly as advice.
Mm-hmm.
And so we all evolve. Anyway, I know what Edward is trying to say. I think the reverse is true. And I think there are a lot of results related to loop Hamming gravity, mathematical results, that if he took the time to learn, he would see what their purpose was in string theory. And I don't like to talk about string theory and loop quantum gravity. I would rather talk about background independent and background dependent.
Sure.
Because I'm sure that they're the same theory.
There are background independent approaches to string theory, though.
I don't know any that work with him. But please, show me one.
There are some talks that I saw, and I can send you over email. Recently, in the past 2 years, I'm sure they're of limited applicability, like it's just for type 2B.
Right. If it's ADS-CFT, it's hard for me to be interested.
Mm-hmm.
Because that has a background on it.
Yes.
By definition. And it doesn't allow me to ask the questions that I want to ask.
So Feynman was extremely concerned with appearing intellectual or appearing smart. And one of he talks about this, he likes to trick people into them thinking that he's brighter than he is by memorizing large sums or cracking safes and so on. And Gell-Mann, I think, criticized him for this, said, Feynman, you focus on the marketing of Feynman and not the physics. Like, focus more on the physics. As you age, insecurities tend to dissipate. Maybe other ones creep up, I don't know.
Yeah, they certainly do in my case.
Yeah. What were your insecurities when you were younger? And
well, they mostly related to women.
Yeah, as they do, right? Yeah. You know Jonathan Oppenheim?
Sure.
What do you make of his stochastic gravity approach?
I like some of it, but I don't believe if he had, there's a part of it, now maybe he's giving this up, but there's a part of it where he says that gravity is classical. And although I don't believe that gravity is quantum mechanical,
Mm-hmm.
I don't believe that gravity is classical either.
Mm-hmm. You believe it's a third option?
Yes, the third option is that space doesn't exist. Time exists and is fundamental. And space and space-time emerge from the fundamental world, which is basically a fancy version of causal sets. And we can show how our fancy version of causal sets allows space-time to emerge in a way that lets there be, in the emergent level, something like general relativity, but only at the emergent level.
Sometimes when Edward Witten is giving some introductory talks, and when I say introductory, I mean to graduate students or upper undergrads, he starts off by saying, like, let's study this toy model where there's only time, so just 1D system. And let's look at the action of that, and then we'll find that particles emerge from
space in one dimension of time.
No, just 1D, just time.
Right.
Just time. Ricci curvature is just a scalar. All you have is just one extra degree of freedom. So are you saying, hey, Edward, you thought you were studying a toy model? That's actually the universe. There's no toys in that.
Right. The problem is that his quote theory is continuous. It has a continuous metric.
Whatever gives rise to the continuum, whether it is a continuum indeed or it's something else, you can always still say it's approximated by a continuum. So why does the continuum... No?
Okay. The approximating by a continuum is a very strong constraint on a discrete set. If you have a continuum which approximates some discrete set, that discrete set, well, think about how many dimensions we're talking about to describe the space. If there's enormous constraints on the continuum space, if it's, let's think about the other way, if it gives an approximation to a discrete set, and so it's very hard to get for example, a theorem of some mathematician who works with Sorkin, Raphael Sorkin. They prove a theorem that a generic causal set is embedded in 3 dimensions. There are 3 elements in the causal order.
Okay.
So that's very non-generic. So in other words, a generic causal set will not approximate any causal order of the low dimension.
Yeah. If you enjoyed this toe clipping, then the full video is linked in the description. You should also sign up for Toe Mail, which is again in the description and the pinned comment. You'll receive immediate access to all exclusive updates from the Theories of Everything podcast. It also helps me communicate directly with the core toe community. You'll also receive my top 10 toes. Think of it as the intellectual version of Quentin Tarantino's Obsession.